Hey Paul, hey Aaron, how's it going?
Hey, Matt.
But Matt, that was a nice, fresh, new introduction there.
I like the
Yeah,
new audio.
yeah, it's kind of like that waiting room, like when you get called into the theater. Like, hopefully, it's not too annoying for everyone. It was my first ever attempt at doing anything in Free Loops like properly, or FL Studio as they call it these days. Yeah, so we've got a bit of a new intro. Let me know if it's annoying in the comments. But hopefully gives everyone a bit of time to quickly press, join stream. So we always have that 30 seconds at the front. Today we have Aaron presenting something that he's been working on. We did a short video on the Devs in the Sheds YouTube channel a couple of weeks, about 2 weeks ago, 1 week maybe, covering micro front ends. So we're probably going to discuss like microservices at the very start, go to micro front ends, and then Aaron's going to show us like the work that he's basically been doing, because I know that some people aren't familiar with micro front ends from a front end point of view. It's relatively new, and and I guess that, some of the concepts from why you'd want to do microservices comes into why you'd kind of look at micro front ends quite seriously for your front ends as well. If you're doing one, you might as well do the other. Uh, Firstly, though, Paul and Aaron, was there anything cool that came out in AWS this week that you want to call out?
Yeah, absolutely. This week on Monday, Amplify OS library was rewritten or rewritten in entirely Swift. So no longer having to use Objective-C to do some of the more complex things. It's all Swift. That's very cool.
Nice. And under the hood, for people that don't know, um, that would be using Smithy, I'd guess. So Smithy allows us to basically, it's how we release like our APIs, our support for CLI, across, a number of platforms all at once. So you've got Boto Free, JavaScript SDK, like whatever else, and the CLI. Smithy is a open source tool that AWS made, and I'll just put it in the guest starring Groot. Yeah, I've got a Groot in the background, and Aaron's actually got a Groot too. My Groot's way up. Like, what? Like, if I go just there, it's kind of hidden. Yeah.
My
Uh,
son always liked that when we were watching anything, reading any of the Avengers books. He would always point that guy out. He's an interesting character.
no,
I
he's a
am
great
Groot.
character.
Yep, yep.
Yeah. It's not the words. It's about like the level, the amount that he can express himself with those words.
Yep.
It's like,
In
yeah.
I and M and Groot, and only in that order.
But you can tell whether he's angry or whether he's happy, excited. Yeah. So anyways, I've put a link to Smithy for everyone in the chat if you want to check that out. But this is what we'd be using to basically produce the Swift native code. We use it for all the SDKs that we have, and it basically means that you can build a model, and you develop support for a language, and then you can kind of release everything with parity all at once, which is really great. Any call outs on iOS native in particular that you saw? Was there anything that it does differently, Aaron, or is it just really around performance and native support and being able to kind of move with where Swift moves faster?
Yeah, I think it was more to do with not having to skill up if you're not familiar with Objective-C.
Yep.
So to handle a lot of the other, like auth and a lot of the other functions that Amplify provides,
Yep.
now being able to support it in Swift. So it's a lot easier or less of a steep learning curve to adapt.
Okay. No, that's cool. And was there anything else, Paul, that you saw that you wanted to quickly cover in terms of
Uh,
releases?
yeah, just quickly, like one of the services that we've talked about and we've showed on the show, which is like Code Guru, which is
Hmm.
our automated code review tool and profiler. We also have another one, and Matt and I talk a lot about this actually, where um, so many organizations have like observability and traceability and alerting alarms, dashboards, looking for when something is broken in your environment. So setting up CloudWatch alarms and so forth. Um, so often you've missed something. So you're tracking your known quantities, but you're not tracking the unknown quantities of change that are happening. So we have another product called Devops Guru, which when you turn it on, it looks at your environment and can detect what normal looks like, effectively learns what normal looks like for your environment and how that's operating. It takes in consideration changes, and that could be changes to infrastructure. It could be like code deploy triggers. It could be, even in a change to infrastructure would be like, let's just say you were altering the provisioned capacity on a DynamoDB table. You can see the before and after effects, and you might be detecting, all of a sudden there's 500s in the application. I'll let you know. So this week, Devops Guru extended support into Lambda as well. And it brought that across to Lambda and the Code Guru profiler. So now there's some more tighter integration between the profile and what's happening in the profiler and Devops Guru there. So you can start seeing like when your code is like hitting bottlenecks specifically in the code, linked back to an event that might have occurred across the platform, so that when you do have a problem where the website's running slow or people are complaining, Devops Guru will alert you to that earlier. But you can also start doing the correlation to say, look at in the afternoon, this specific Lambda function, this line of code is now taking a real beating. This is the area that we should focus our efforts on, rather than just increasing CPU capacity and hoping for the best. So I thought that was worthwhile too. And probably at some point, I think we'll do a show on Devops Guru, and we'll show what that looks like as well.
Nice. And the one that I was a little bit excited about this week was support that came for Fault Injection Simulator. So you can have logging through Fault Injection Simulator captured in both S3 and CloudWatch. But not only that, they also extended some of the chaos engineering experiments with Fault Injection Simulator to cover like stopping ECS tasks, which I thought was really nice. So we haven't done, like, Paul built a really cool tool for chaos engineering to test out Fault Injection Simulator. But we haven't really shown much of it on the show. So I think that's actually like similar to Devops Guru. That will be coming in the next couple of episodes, I reckon.
We can do that. I had that little chart that went up and down and showed you whether it was working or not, and you could kill it. Yeah, that was pretty fun.
Yeah. It's just, I don't know, like people in the chat, like, I don't know if you have fun destroying things, but it's like one of my favorites, right? So, you build an app, you think it's resilient, it's talking to third-party APIs, talking to other systems that you have in your organization. It's like, is this thing really going to fall over? Like you think that traffic coming from multiple sources, it's going to be fine handling that, it's going to be able to scale up. But, what happens if one of those sources goes down? What happens if, one of your containers goes down at the same time? What happens if one of the third-party APIs fails? So chaos engineering is really cool to kind of test the edges of like what will actually happen. And then you can build in more resilience to make sure that your app's still running for consumers or end users. Chaos engineering is something that
it also allows you to, when you do that, you can talk about like the stampeding herd problem, which is always a good one to bring up. So many people don't know what that means, and it's basically like one service goes down or one piece of application, pauses or throws errors. You've got like retries or a mechanism to slow down and try again a little bit later. When you don't, that works really well if this platform's down for like a second because it tries once. But if all of a sudden all your services are trying multiple times, then not only is one part of the application service broken, but you've started destroying everything downstream as well. So probably a good one for us to talk about and bring up on the show.
Yeah, so we'll cover that in more detail in another episode, but really excited to see Fault Injection Simulator like evolve. It's been around for about a year. Definitely a service to check out if you're looking to increase your resilience into your own applications. Load testing is always an important thing to do as well. So that's something else that we might quickly touch upon when we do that episode. But today, for everyone in the chat, let us know where you're from. And let us know if you've experimented with microfrontends before, if you've heard the term. What I might do is, firstly, I guess Paul or Aaron, what was the benefits of the back end side? So microfrontends are really a replication of what's happening in the back end. But what was the purpose of like microservices in the back end? I'm sure most people will know what we're talking about, but just in case anyone's joined and they haven't really heard the term before, what's kind of your take on it?
I guess it would be ability for a specific domain or chunk of the application to scale up and down and be like self-isolated. Once you have you're the service that looks after itself and has a well-defined like interface, somebody else or another part of the team, another application team can interface with your application. They know what the interface looks like, but they don't get mixed up in the details of like how you've implemented that on the back end. You don't have all of a sudden, exposure of your database schema or your schema of your application put forward. You just have an interface, which means that if you're in a team that says, look, at the moment, this is how we provide the data and we need it at 100 requests per minute, the other parties, they know how to consume that data, but your business has taken off and you need to scale that at like 10,000 times per minute. Because you have an interface, you can build your new solution towards that interface, and no one needs to know that anything's changed in the back end, and all of a sudden you've rebuilt a back end system and you know that the other people can interface with it without it breaking. Whereas if you're, maybe more traditional where you're building a monolith, you start building these things, you're taking into consideration because you're adding extra columns on the database to store the data, or I don't know, something else to partition the data. Everybody else that's interfacing with that needs to deeply understand what it is you're doing. So I guess that's probably the main benefit that I see. What about you, Aaron?
I would add to that. Absolutely everything that you just said, 100% agree with in terms of the technical capability of scaling, resiliency, high availability, everything like that. I would say from an operational point of view, it also allows for the isolation of independent teams or independent services to be managed by different groups and teams that can then interact with each other, not interact with each other, like from an operational point of view. So then, yes, still they need to have their integration requirements, so their contracts of what data is going to be sent where and who's going to subscribe to what events. But it allows to what you were saying before, Paul, the domains. So you can now produce a domain-driven design system, end-to-end system. It's not just a monolithic saying, all right, well, we'll do payments here and we'll do shopping cart here and stuff, and the one team building it. It's now cross-domain application team. So big enterprises can now say, right, we're going to run this service or set of services within that domain. We're going to run this service or set of services within that domain. And so then even you can get down to like atomic level functions. Like if we get into serverless and start doing, Lambda, you might have one Lambda that does one function, one Lambda that does another function, but you might have within that domain an event-driven process that has, 4 or 5 different microservices, which could be serverless Lambdas or event-driven, Event Bridge or SQS or whatever, to form the service domain, and then they're communicating with different teams and different services and the like. So it really helps organizational scalability in terms of operations. So taking on that DevOps approach and being able to break out into multiple different teams to develop different things rapidly, as opposed to what you were saying before, that monolithic approach is very much the old school waterfall approach where, we've got to cover this requirement, then we've got to cover this requirement, and then, hey, we need to make a change to the database here and go back and fix all this that is affected. And it just slows production down operationally exponentially.
Yeah, I think the thing to add to that is, like, if you're a startup, it's perfect to build a monolith to start, right? Because you can always break things up into microservices. So my view is always when your team splits into multiple teams and it becomes really hard to start to like work across that one code base, that's kind of when you want to look at like breaking out into microservices. When you've got an app and you've got a lot of complexity, a lot of things that app's doing, you might want to break it out as well, just so it's more readable. Like for new developers coming in, like people go, for this part of the service, that's where I go, and over here it does that part. And so, you can split out for that reason as well. But they've been game changing, right? Because you get so much more resilience as well, because it's basically like this mini app, APIs. You've got the ability to communicate with other apps that are running, and yeah, like from my perspective, I'm trying to work out where I'm going here. I did have a point originally, but from my perspective, it's just like nice and clean. Like you know what APIs endpoints you're dealing with. Everyone else knows what API endpoints your app relies on, and you can put resilience in there. So basically, when a section, one of the microservices goes down, it's not going to break your entire, application that you've built. My last company used it for sentiment analysis. We had some issues of sentiment analysis sometimes. And so that was its own microservice, for example. And whenever that had issues, instead of breaking everything to do with the application that we're running, it would just turn off the sentiment until sentiment started working again.
Yep.
And I got there in the end.
Exegiato has the perfect segue for you, Aaron.
Thank you.
What does this have to do with front ends? Perfect segue.
That was actually the next question. So
yeah.
Yep.
Absolutely. Let's bring up my screen and let's go into, before I jump into code and show you how it all works, to answer that question exactly, from an operational point of view, Microfrontends, again, taking on that same microservice capability, allows you to separate the development of a front-end component, whether it's a full SPA app or controllers or like the old school web components that you've got that doing specifically functionally different things on the one application. It allows you to separate those web components out into separate development environments, separate DevOps processes. So now you've got a separate code source. You may even have a backends for front ends type approach. So now each of the different micro front ends has its own backend, has its own API that it's requesting and receiving data from. If you're developing a very large enterprise system, you may end up having a microservice environment in the backend, but you may only want to expose certain things to certain micro front ends or applications. So you would develop a backend for front end, which may be just a API to talk to specific, services or components or whatever it is. So without getting into the complexity of the back-end side of things, from the front end, it allows you, again, to separate your development team code base, processes, and also take control of the actual application deployment as well. So the full CI/CD process, not just the development and release, but also deploying it. So I'm going to show an example soon of two apps that are running in isolation, but actually using the same underlying controller. So the one app is using the code source that exists in its app, and the other app is actually querying remotely to pull that controller in and use the same controller. But essentially, before I jump into that, I want to talk through some of the different scenarios and why I've chosen to do the specific demo that I'm going to do, because there are two very common approaches. One, I would say, is common more so from the ease of use and the capability of understanding how to set it up is quite easy and quick. And that's the picture that you see here is the container monolith using micro front end components. So querying in micro front end components with the same framework. So in this case, let's say we're using React and we've got three micro front end components all in React. And then we also have some monolithic, I'm calling them monolith components because they're React components within the actual monolith app that's calling the other micro front ends. There are some complexities around version control, like when you're using one framework and then embedding micro front ends inside that same framework. There's some things to be aware of in terms of making sure that you're using the same dependencies, so same libraries. In this case, it would be React version 1 with React version 1, or in this case, I'm using React version 17 for embedding. However, you can get around. So what I'm going to go into is in this same process, there is a way of getting around not having to use the same version libraries. So, and the reason why we want to do this is around the ability to service the back end, so that the micro front end itself talking with its own back end, and therefore the one operational team managing the back end for that front end, managing the front end. Obviously, there still needs to be some coordination. So there's a central architecture team or a central app team who is saying, these are your UX and design, this is how you do it. This is how it has to look and feel. But then functionally, it's up to the individual team. Now, there are some advantages to doing the same framework, in so much as what you can see here, you've got the monolithic component, and then the micro 3 and the micro 1 also talking to that monolithic component. That would be through using the actual framework's capability to hoist data. In this respect, state management. So if we were using React and we're using state, or if you've applied, say, a Redux pattern and you want to manage a application, data store within the application itself using Redux or some other idempotent based, action and data retrieval, you could do that and then communicate through your micro front ends to that monolithic data store, or to that monolithic component that's housed within the monolith. The problem with the other, say, embedded isolated one here is if it's not using the same React library, in this case, if it was React, then you would have an issue with hoisting your scope or using the scope of the monolith inside your isolated component. And so the only way that it would be able to communicate is either through its backend and sending data to the backend, or in the same way that Micro 3 is talking to the window or the DOM, this guy would also be able to talk to the window or the DOM. So it would be able to hoist a function into the window or read from local storage or cookies and whatnot. But it's a more roundabout or isolated way of communicating. And that brings me to the other pattern. So this is sort of more common, but what I would suggest is more recommended is the isolation of framework. So where we're framework independent, we can actually create a monolith, which if you were to consider how we develop a React app, all we're talking about is a single div with the root or, app div, which then the DOM renders into. That would be the same across whether you're using Vue, whether you're using React, whether you're using Angular. You could then develop smaller components that render onto the actual the DOM. So you've got some physical DOM in the HTML file, index.html, which then the independent frameworks can render into their specific DOM element. The advantage of this is then you can then tie together each of these frameworks then using the window. So whether you're using a session storage, local storage, cookies, and whatnot to communicate between components, but you can also create utilities or libraries that can then be used between those components from the actual monolithic container. And what I mean by that is, let's say we created a monolithic container that had a observer library. So it creates a library that allows you to create a event and subscribe to an event. You would hoist that to the window. So it's sitting in the DOM in the window. And then every other micro front end can share that library by querying the window function by saying, all right, window.myObserverPattern subscribe to whenever a string-based event, so data for a message gets sent off, I want to fire this function. So the actual micro front end is adding it could be a Lambda, the JavaScript type Lambda, not the AWS Lambda function, into, or creating a separate function callback and adding that to the observer subscription. And then when one of the other micro components or micro front ends emits its change and says, yep, I've sent that message, anyone who is subscribed to that message will then fire off that function. And hopefully that function is, give me this data and do something with it. And then you can basically hand the data that one of them is firing out to the other two, or to all that have subscribed to that specific event. So this is probably a more preferred method. It's just a little bit harder to get up and running because you actually need to develop your own monolithic container utilities and properties that you can then use. There are libraries to help with it, but it's a little bit more custom work in the container before actually using the micro front end. So what I'm going to do is I'm going to jump in and demonstrate this pattern because I want to show you can actually use and what it takes to use different version of the framework by doing the hoisting outside of the actual component itself.
Just before you do that, I guess who's using micro front ends that you know of, Aaron and Paul? Like, have you seen them in the wild? I know that it's a recent topic that's come up, but I know that some companies have been doing it for years.
I know of like banks that are doing it, Australian banks.
Yep.
I worked for an online wagering company and we did it, but we did it a few years ago and it wasn't quite as clean, but it was still followed a similar pattern where we provided complete isolation for separate, we were using React.js, so complete isolation with separate React components that were able to be imported and injected directly in. So you could have your team designing and building your widget, and your widget was plugged into like the larger application so that your team could, build as much as whatever you wanted to do and had no dependency on the core piece of the application. So you could deploy completely independently. And exactly what Aaron said, we were using like Window to do the share between and shared libraries. So we were doing those tricks there as well. But I also know a lot of the retailers are continuing to expand their, what's happening online. And the last few years have pushed so much onto online that the priority is way at the top, and the experience expected from consumers is so much higher that these organizations that have got like large, slower moving applications, they've gone now to start saying, look, we need to update the checkout, for argument's sake, of our application. So we'll rip that out and we'll build a micro front end for the checkout, and that's completely isolated. We can build that independently. We don't have to be stuck with, an older version of, for argument's sake, jQuery or something. We can continue to build forward in that area, and then reuse it later when we migrate the rest of the website. So I would say most of my customers.
Nice, and I know Amazon's used it since the start. Like, there was a button. I think it was the wish list button or the add to cart button. The back end for that went down, and it caused the website Amazon.com years and years and years ago to go down. And so we've kind of had that micro front end design to add resiliency to the Amazon.com site. I know some banks in Australia that are doing it, definitely. And I was also going to say, this is something that just like how we talked through microservices on the back end, when your site grows, when you've got a large React code base, this is something that you might want to start separating elements that make sense into their own applications, not just for resiliency, but to make it easier for multiple teams to work on the one site. But also, like, if developers have a choice, like some things were built in Angular a while ago, you're using React now, some people are using Svelte, you can kind of mix and match these components. And I think the architecture that Aaron did show just beforehand, the best way to do the interaction is through communicating with the DOM. So I quite personally like this design, because it means that I can run my own app completely independently, like my own Angular app. I can pass context and information between that Angular app and the React, core app. Let's call it a core app. And so in that way, like, I can run that. And then if I have another React app, I could run a whole different version of React with its own packages at different versions as well. So it just means that your team can be completely independent and not reliant on every other development team that's working on the site at the same time to have to kind of get in line with updates, or, have to kind of hold the fort on updates, like waiting for the core version to be updated to a particular, framework version.
There's a good comment here, Aaron. Maybe we'll just get to this one. And so Tony Davis says, beware of shared state Redux store for multiple microfrontends.
That's a really
as it introduces coupling, and prefer events for loose coupling. So because this is one of the first things I talked to you about, this solution. Like, how do you handle this with Redux, and how do you handle state here?
Yeah, so that's a perfect call out, and that's exactly why we recommend this pattern. It's for handling the actual decoupling of components through the window. So you can actually create your own, as I said, like your observer pattern or whatever it is, the same that you would do for your message broker. You can actually put that into your window. So you've got your JavaScript, like your monolith container in a way would be your glue that embeds all of the window functions that your that your micro front ends can then query from the window. So you've always got that window. You've always got the DOM as the root level, component between all of your front ends. So absolutely, decoupling whenever possible. I would absolutely agree with that. I was going to say, in terms of who's doing it, I can say that I know, working in the GSI team, a lot of the larger systems integrators are building micro front end based solutions for their customers. But one enterprise that I've seen do this really well is Hexagon SI. So they're a geospatial company that developed like a dispatching system. So it's actually a map, But then when you're interacting with the map, they've got like a right-click context menu that brings up different components. All of the different components are actually micro front ends. So you can right-click, open up a component. This could be information about that location. It's sending it to the back end. And then you might have, based on that information, it might want to take something and interact with something else, like another component based on an alert or something that you've set up in the front end. So it's now using the observer in the window that then sends that to the other component. So you've now got two components interacting all on top of the map, and it's all micro front end. So they're all independent of each other in terms of how they execute.
The other thing is, in this design you can use shadow DOMs as well if you need context that's just for your particular app, or you wanna kind of branch or clone that context and modify it but not pass it back as well. So web components kind of helps with that element of having like a shadow DOM in this design. The other thing I was gonna say, like, and I know we're kind of holding you up, we have one of the guys at Amazon has written a book recently, and I thought I'd just share it. You don't need to buy it. I'm not asking anyone to purchase anything. But Luca has really good insight. I think he's got some blogs. He's definitely worth following on Twitter, having a look up. He's done a lot of work on Microfrontends and put a lot of thought into it. So he's written his first compilation of all of his knowledge through this book.
I absolutely recommend reading it if you do want to buy a copy of it.
Yeah, maybe if people are attentive, maybe if we have a question at the end, maybe we'll just purchase a copy. Yeah, we'll give away a copy. Let's do that. Like,
that's generous.
Random. Let's give something away. Like that wasn't planned. But yeah,
free is always a great price.
I'm more than happy to ship a book to someone. But Aaron's going to have to think of the question as we go. So Aaron, you're going to design one, right? Like so. So this is a React app. Just go back just very quickly, because I know we've kind of detoured a little bit.
I'm building this guy. So what I've got is I've got my monolithic container, and I'll point them out. And then I've got a in this stage in the first one, I've got a monolithic component. So I've got a React app, a SPA single page application with a React component, and that's basically all this first one is doing. This is my SPA app calling a local controller app. And I'll jump into the code very quickly, but you can see here that I'm doing click to increment. I'll refresh the page so that it starts at 0 again. So clicked 0 times. There we go. I'm incrementing the counter just by clicking the function. It's very simple, a button with a on-click event and then some state to hold, the counter. So that's my single page application. And what I want to do is I want to expose that single page application controller. So just the controller app out of my SPA into as a monolithic front end as a micro front end into a different monolithic container or a different container and call it remotely. So in my other app over here, I've got this main app is calling the remote controller app. And let's refresh again. And I'll show you the state isn't shared between the two. So you can see that I've called it 6 times over here, but it's now 0 over here. And I can increment the counter. Let's make sure to do it more than 6 times. And it's still 6 times over here. So there's no shared backend. All it's doing is it's sharing the actual controller logic. So the actual JavaScript React component as a exposed remote component that I can then query in and render into my other application remotely.
I think what you said there, Aaron, is it's an exposed remote component. And that's the differentiator. This code isn't copy and pasted in 2 databases. Correct. This code is the controller is published as something that's consumable by multiple applications that in render time is pulled in and used at that time. So 2 applications using the same code. The code is shared from a centralized location.
Absolutely. And on top of that, I'm going to show you a little bit more complexity as well. This single page application is running React 17, version 17, right? This single page application is running release candidate 18. So this is a more modern version of React, but we're still running the React 17 controller inside the React 18 app. And the way that we're doing that is, and that's what I was saying about removing the actual use state and hoisting it outside into the app. So I'll get into that in a second. But to your point, Paul, if I was to be doing this remotely, then here's my S3 bucket. The first app that you saw is my controller app. And then obviously when I've done my deploy, it's chunked it out and everything. I've got my chunks here. I'm creating this remote.js, and I'll show you how I'm doing that. And that's what's being called in. That remote.js is being called into my other app is called the router. And that's actually that's very simple HTML main.js, and that main.js is the one that's calling the remote.js from the other app. So these 2 applications, and there's a third here, I won't click into it, but this third is actually my React release candidate 18 libraries. So it's not actually embedded in there's no React library in my router project. It's pulling React in remotely as well. The only one that has React embedded is the controller project. So then basically I would use CloudFront, and I'll just drop this quickly into, or if one of you guys, I think I've already done it, if you can drop that into the chat, I would use CloudFront to basically set up a CloudFront distribution for each, the controller, the libraries, and the router as separate endpoints, which then, if I was to set up my DevOps and I'm doing my build, I would then send that URL as an environmental variable to each of my applications to then know where to query remotely. So it's actually querying from these 3 remote locations. I can store it all in one S3 bucket, or if I'm different teams, I might have a different way of hosting. I might have a container in one team. I might have S3 static hosting in another, and I might be sitting on premises on my own web server for another. It doesn't matter where it's hosted. It's just the way that it's broken down and generated. And so before I jump into the code, I'm going to throw another link at you. This is what's doing all the heavy lifting. And very soon, I'm going to jump into the code and show you how. But with Webpack 5 comes the module federation. And this is to Paul's point of it's not copy-pasting the code into your app. It's actually querying the code remotely at runtime. So we're not actually having to do a build and build the actual library into your bundle, and then it's bundled out. It's actually creating a container. So module federation creates a container with a remote endpoint or locator, or saying that I will have code coming from here, so that during build time, it doesn't build all your dependencies into your bundle. And it says when you query at runtime, it'll come from this remote location. So let's jump in and have a look at that. So first of all, let's look at our single page application with our controller, and we'll show how we've exposed the actual controller. So first of all, Index and Bootstrap are a feature of the module federation. So this is a structure that you must follow in order to be able to handle remote federation or module federation of your Webpack modules. However, the Bootstrap itself is just as simple as your normal index.js when creating a React app.
So don't be confused with Bootstrap, the framework, the layout framework.
It's not Bootstrap, the front end. This is called bootstrapping. So my Bootstrap is a Bootstrap for React, for Webpack module federation. It's not Bootstrap library. So what you can see I'm calling in here is, as I said, I've got React DOM as components of this this project, and you can see that in my dependencies I've got React DOM version 17.02. So that's what we're using here. It's importing them, so that's getting bundled in. And if I wasn't doing module federation, it would be bundled into my entire bundle. So the way that I'm doing this is actually separating out the React bundling from the actual bundle that I want to share, and it's kept as a separate bundle. But we'll get into that in a sec. So all I'm calling in is my app, and let's go over to app. All app is doing, I'm just doing some very simple color coordination. So you can see that the container is blue and the text is white, and I'm adding that to my divs. All I'm doing is I'm importing my app controller and also setting up the state. So this is where I'm setting the state. So hoisting it outside of the controller itself and handing it into the controller, as opposed to managing the state inside the controller. So all I'm using is the React state for 17.02 in this case, and a very simple count handler, which is basically just taking the count and incrementing by 1 every time I click it, handing that to the app controller. And my app controller, all it's doing is receiving the set count handler and the actual counter itself. And it's very simple HTML. So there's nothing to it. It's a button with an on-click event, which is firing that set count handler off. Now, if we were to get into something more complex, your controller or your app or the bit that you want to expose may have the integration with the backend. So you could actually be talking to APIs. You could be doing queries to get data. You could be doing queries to send data. So mutations and queries based on whether you're sending, updating, or receiving data, all of that could be happening here, and that will still happen. But in terms of the things that we want to expose to, say, the monolithic container, that's where we hoist them out through sending them through the actual controller, or the, what do they call it in React? Component, the component properties. That's it. It's as simple as that. Now, the fancy bit happens in the Webpack. So in the build, that's where we tell it to expose the remote.js, what we want to expose, and it will do the chunking based on what we want to expose. So let's go into the Webpack config. And we can ignore the standard Webpack config. This is just your standard Babel translation or transpilation from React into ES6. So we want to look at specifically what I've done here. I can get rid of these because I'm not using the remotes at the moment in this little guy. All I'm doing here is, now, the controller for your module federation, or the name for your module federation, must be the same as your name for your actual package.json. So this is your app name. So that's one thing that doesn't change based on whatever is in your package.json. The rest is, so file name. Remember I showed you in that S3 bucket before, the remote.js? That's generated by the module federation. So all I've done is I've said, we want to create a remote.js, and inside that remote.js, all I want is the app controller. So this is the name of the class that I want to call it. And I want to pull it from my app controller JS in my source. So it's just going to pull this, and without the React, and expose it as an app controller class, essentially. If you know how Webpack does its minification and its bundling, and you go and you look at your minified bundle, you're just going to see a whole lot of, characters equals numerals equals, it's all minified. What this is doing is it's actually creating a string that is, so a strongly typed string that's saying, all right, this module is called app controller. So now I'm exposing everything that is app controller into an object that can then be queried as app controller. The rest is fairly straightforward. This external template remotes plugin allows me to say I'm going to use a remote location for importing in libraries. At the moment, I'm not doing any of that here, but I'll show you that next in the other one, in the remote one. But that's what allows me to say this is going to use a remote location address to then be bound to the library that I'm importing through Module Federation. So
we did have a question, Aaron. So
yeah,
Grizzle said, does this not introduce a single point of failure, as the remote app can now break multiple downstream apps?
Yes, very good point. So yeah, there is, if you make a breaking change to app controller, not only are you going to break your SPA here, but also it could potentially break whatever's remotely querying it in. So that's a great question, and this is where we support CI/CD pipeline testing. So this would never be done manually. I would never, the way that I'm deploying this to do this demonstration, I would never manually make a change and then deploy it directly to my remote calling application. So this is actually being used in one of the service teams that I'm involved with here at AWS. The way that we're doing this is we actually go through a whole pipeline. So we make a change, we commit that change CI. We then do unit testing. It gets tested if there's any code breaking changes. If there's no code breaking changes, it goes to the next environment. It gets functionally tested in that next environment. If it goes through all of its test environments, it graduates to the production environment. It actually gets deployed into a version control bucket, right? So it's no longer just URL/remote.js. It's URL/version/remote.js. And then that allows the remote caller, so the one that wants to upgrade, to say, you know what, I'm ready to move from version 1.1.0 to version 1.2.0 or 2.0 because it's a new release, and manage it that way. I'm not going to go into the complexity. We also have a version updating mechanism that tells the remote that there is a new version, and they can opt to automatically go to the next version whenever it loads. There's a whole pipeline around that. Probably not so relevant for the actual what we're doing, but it's a great question. Yes, you can essentially, in the same way that you would introduce a breaking change in any application at the code level, you would need to make sure that that doesn't get to production through the standard CI/CD process or through your standard pipeline process. So what we've demonstrated is a single page application with a controller that has some function. Now I will jump over into, now you can see where we're using. So that other module that I was telling you about with the remote location, that's this guy. So that allows me to set a controller URL and libs URL for a remote location. So that would be, I'm running this locally, but if I've got my CloudFront distribution set up, that would be my CloudFront distribution for the controller, my CloudFront distribution for the libraries, and /version if we want to do our version control, through our pipeline and whatnot, so that we can specifically lock it to a version and upgrade it to a different version when we're ready, or have some control function here that might query the versioning and update the /version number for the latest version released.
We did have a question from Panther Egg as well. So just do we have a solution library that allows for this type of design with, like CloudFormation, Terraform, or CDK to create the resources? So my thinking's we don't have a solution library or template or anything for this type of design at the moment, do we, Aaron? So
not yet. This you could consider Devs in the Shed as the breaking ground. So I'm working on these. This POC that I've put together is a very cut down version of stuff that I'm working with customers and actually with the service team here at AWS. What I will be doing from this is, writing a blog post like I've done in the past with other breaking ground features in Amplify and the like. I will be putting a blog post to explain and describe what's happening. But then, yes, I'll start to put together AWS samples so that you've got, say, a JavaScript or a TypeScript sample. I can then put together a CDK app with, constructs so that you can then just go and deploy it and make your changes yourself, which would include, to the question before, the CDK pipeline, so that now you can do all of your pipeline management through your CDK app and then just deploy your 3 different apps out with their different endpoints managed in this way.
Yeah,
that's all to come. Like, we haven't got there yet.
Well, the other thing is just from an industry perspective, like Microfrontends browsers only really got like some of the features that really like help make it more implementable by everyone. And React's, started to add better support for these types of things within React 18, etc. So it's all actually like super cutting edge new. Like I did mention, AWS did do it way back in the 2000s. And we've got lots of companies that have their own patterns to do this, over the last 5 years that we've seen, because everyone has large websites these days and they need to break it up to make it easier for teams. But, like what we've seen in the last 6 months is a change by both browsers, both React and all those types of things to better support this type of pattern. Absolutely.
To the point before, like that Matt was saying around like how new this is, what I'm demonstrating here has only come about because of the release of Webpack 5. So with Webpack 5 and the module federation, prior to that, with module federations, to Matt's point, the way that we were doing it on the AWS website was very different. It follows a similar pattern, but it's a very different, like under the hood approach, and a lot more manual. So this has automated a lot of the stuff that we would have written to then expose that underlying microfrontend code. So this simplifies things a lot.
The way we were doing a lot of this in the past was, yes, we had the individual teams building the piece, but it still required a recompilation of the major app to redeploy it because it was still bundled in. You weren't able to access that code remotely. So we had independent teams building their codes in isolated areas, but deploying it still required a deploy of the whole app.
And Tony Davis has asked, what do you think of like single spar? The single spar kind of framework, I guess I'd call it. I haven't really thought too much on it, but I think that's a really good way of doing micro front ends that we've seen a lot of companies implement as well. Most companies usually start with a React base. And so, they've already got their routing, they've already got their main site. There would be a bit more of an architectural change to get to a pattern like what Single Spar has, if I remember correctly. I don't know if Aaron or
Same.
Yeah.
The difference between React and say Angular or other, like single spar, is React is a library, whereas single spar, Angular, these are frameworks. Yeah, so there's a very opinionated way of doing things with React. For people who have come from, say, jQuery, and they've built out libraries which have a bit of, exposing HTML DOM, and they've built all that themselves. It's easy because you're actually cutting away a lot of what you had written in jQuery when using React, and now you're just having to expose your JSX. So here is your HTML with a little bit of JavaScript, and bang, you've done a component. That component can actually be embedded in. I've seen applications built on Angular with React components embedded. So it actually is a lot more lightweight, a lot easier to then embed in other things. I've never seen an Angular app or component embedded in a React going the other way, just because of that opinionated way of deploying your application framework. I'll just check if there's any other questions before I move on.
I think you're good to move on.
At the moment, right?
Yeah.
Good. No worries. So the other thing that I wanted to show you here is what I mentioned before, where I've got the libs library, and I'm not actually importing the actual. If we look at dependencies, you can see I've got dev dependencies, but there's nothing actually in my dependencies. So I am actually not requiring the actual build. So when Webpack goes and builds the bundle, I'm not requiring React in this at all. What I'm doing is I'm exposing the libs. So before I jump into this, I'll just quickly go over to the libs project. Index.js is intentionally left empty. It's required for the Webpack to run, but all I'm doing in Webpack is the same as what we did with the other one, but instead of exposing my own code, I've created remote libs.js. I'm exposing React from the Node packages and React DOM from Node packages. So my Node modules package. So all I'm doing is I'm saying, I want to expose React class from React Node modules package. So you can go and add your packages here. Now I could go and add additional, when we were talking about the second pattern, I could go and add utilities and functions. If I want to write that observer class that we hoist into the window that then other modules can call, I would write that here and expose it so that the other two, if they wanted to use it in their application, not for the remote, but for actually using it, they could query it in as a remote library. So that's all that this is doing, is exposing that remote libraries. And then if we jump back over here,
what happens if one of the microfrontends has some additional Node packages that it wants for certain features? Like, where would those sit within this particular model?
So they would be bundled into the remote application. So if I had additional packages in my original SPA for that app controller that are required as dependencies, not dev dependencies, then they would be bundled into that. Yeah. So when I expose that remote.js class, that would be included in that bundle. However, that actually brings up another really good point, is you can see here that I've actually commented out this shared. I can actually specify that I'm sharing libraries, or I'm sharing components, or sharing libraries in this case, so that I'm not going to import it twice when I'm bundling, or when the Webpack is bundling. So great call out, because now I can actually have a React app, or have a JavaScript app with a package, a dependency that then is used in my bundle. And then if I'm sharing across, I can say, all right, two of these different ones are sharing it. So just add it to the shared one, and it'll create a separate bundle and query it in. So before I move on and show you what the remote's doing, remember we had in the last two with libraries and controller exposed our remote.js and remote libs.js. So in my monolithic container, all I'm doing is I'm saying, in the same module federation plugin, now I'm doing remotes. So I'm saying that there's remotes. I want to create the controller object, and it will come from the controller class from my remote URL, and it will be looking for remote.js. So remember this external template remotes plugin, that's the guy that's saying, find the controller URL, which is right here, and libs URL. So those two are done at build time, and then implemented there. So we are creating a controller object from the controller class at this remote location from this remote.js, from this file. And that creates your container, with your remote object that when at runtime you need it, it will query in. And so this is how we're doing it at runtime. If we go over to our app, so actually you can do it in two ways. We can still query in the same way that we're doing our when we'll build a React app, we need to statically call, we're calling React, but I'm actually statically calling this from my remote library. So it will use the container to then say, well, you will be getting these from that remote library, but it's the same syntax. So when you're writing your JavaScript to import, it's the same syntax. It's Webpack that sets up the smarts to understand whether this is a local library, this is being built in, or coming from the container from a remote library. And the other one is the dynamically importing. So using lazy loading in this case, I'm saying using the app controller, I actually want to use lazy and suspense. Mm-hmm. I'm going to import from the controller class my app controller. So from my controller object, my app controller, which is the class, which will then be lazy loaded into my app controller object. Then, last but not least, when we actually display this through our application, all I'm doing is exactly the same way as we did in our local app. Is I'm saying, for suspense, if it takes a long time to load, add a function here to go and do stuff, or just display the text loading, and then when it loads, app controller is here, that using the same way that I've used it in my other React app. Set count obviously is coming from this application, so we've hoisted it up to the local app class or function, and then we're setting the handler and the counter through the properties. So if we go, so I can't go into app controller because it doesn't exist. It doesn't exist in this project. It's over in my remote project. So now when we run our app, you can see, if I do it you might see very split second refresh. You might see a loading. Oh, that's my browser taking time. There you go. Split second, it comes up loading, and then it loads the app up. So this main app calling the remote is actually using the remote React library, and that is React RC 18. And this is the controller app, which has come from our React 17 app, which is just pulling in the functional component, basically. So that's one way of doing the micro front end, and specifically being aware of when using different libraries or using different versions of those libraries, is taking the actual the state management and any functional control that needs to be exposed to the monolith out of the actual app controller and hoist it up to the monolith. Whereas everything else, if we wanted to, as I said, implement, say, app sync, so we could do GraphQL querying, we could have that in this app controller, and that could be querying GraphQL model to make query data, make mutations, update data. That can still happen all inside the app controller because it's now central to the actual application. So that's about it. That's it in a nutshell. If we've got any other questions, they're probably the important things to remember in terms of using different versioned frameworks or libraries, sharing libraries. So I can share, if I wanted to now, I could update the app controller project to import the remote libraries and start using React 18 instead of using the React 17, remove the dependency from the local build on React, and then both of them using the remote library. So that's one way we could, say, centrally manage libraries for all of our microservices. And then that doesn't just have to be, public libraries like React and the like. It could be your own personal libraries. You could create your utilities, any classes that you want to share between development teams developing their own front end. And then the only thing that I would do on top of that is obviously separate my monolith out to not be using React. It would be querying a React app, querying your Vue app, querying your Angular app, whatever framework you want to use or library you want to use, and then rendering onto the DOM independently of each other. And that's it.
Very nice. Any questions from the audience? I know we're right on time today, but we can stay for another 5 or 10 minutes if there's questions. There's a lot of different ways that you can do micro front ends, right? Like no one's designed a set pattern, but this is really good for a number of projects that Aaron's got going internally that he's been working through.
Yeah, like I said earlier, there's so many people facing that same problem, and I've seen before many times that they might be importing multiple different React widgets, or they're still moving along that path, and their website now is 6, 7, 8, 9, 10 meg of data coming down because they're doubling up on, the dependencies that they need there. This also would mean that, let's just say, for example, you had a shared utility class that did a mathematical calculation, for example, and that was shared broadly across many different of the front ends. If an issue was found for that, it doesn't require you to redeploy the other front ends. It's in the shared library. Redeploy the shared library, all the other front ends pick up that mathematical fix and push it all the way across. So, I mean, it introduces the same problem. You can, have the breaking change that breaks many things, but can also speed up when you do a fix, which is probably why we say, testing is so important.
Yeah. Two really important things from what you just said there, Paul. One of the reasons why we chase this at the build time bundling is to remove that extra bundling. So the libraries that are shared, remove them out of the bundles that don't need it, and then share them across. So we obviously, when we're developing web apps, we've got to, we don't want to be getting over 200K when it comes to our JavaScript libraries. If we're getting over 200K up to 300, 400K, it starts to add load time, or it starts to create additional 400 to 900 meg. That's huge, for a web app, because there's so many apps bundled in and you've got so much going on. This allows you to separate all of that out. And even if it's just the one development team developing the one app through different components, it actually helps to reduce the bundle size. That was the first one. The second one was, as a hint, one thing that we're doing is that remote libraries, instead of just sharing in the React libraries or whatnot, we're creating essentially remote service classes. So we can say this utility is actually talking to a backend, and it's going and doing some, say, recognize, object recognition using, AWS Recognize, or feeding it text into Textract. Yeah. So it's actually doing some OCR or text recognition as a library that we can then share across all of that. So instead of saying, hey guys, you need to do some object recognition and you need to do some object recognition, and then setting it up in their backend, you can say, all right, we want to set up an object recognition team to just go and do the backend and expose it through an API. But then we'll create a very simple library that we can share across all of our front ends to then use that same API, instead of individually querying the API from each app.
Yep. Tommy Dachi says, is there a GitHub example link? I think at the moment there isn't, Aaron, but I think you're going to, as you mentioned earlier, you're going to do a post and do a formal piece of documentation and publish that up. And we'll share that.
We'll share it through Devs in the Shed when we release a blog and the AWS sample.
Cool.
Perfect. Well, if there's nothing else,
Tony Davis has got one more comment. If Microfrontends bundles are coming from different domains, how would you avoid cores? That would be fixing the origins file.
Yep. Yeah. So you have to establish a trust relationship between the remotes.
Yep. I mean, I'm sure when Tony talks about cores, any developer that's ever, if a developer hasn't hit a cores issue, then maybe they're not a developer.
Keep digging deeper. Just keep digging deeper. You'll get there.
I've got, what about a 2D side-scroller game in Lambda and really utilize my company's production service? I don't think that's the model here. But if you want to create something in Phaser.js, feel free to go and use that. You can make some pretty cool 2D side scrollers there.
And if you do that and tell me what your remote library is called, I will then import it remotely into one of my applications and demonstrate your 3D scroller in one of my micro-front-end applications.
2D. 3D is going to take way too long.
2D scroller, yeah.
And somebody, what you're doing, just prompted me, I think I'll share this library, it was shared with me the other day, Elevator.js. If you need to scroll to the top and you don't want to be super boring about doing that, maybe check this library out. It has nothing to do with me, but I thought it was interesting nonetheless.
Cool.
Perfect.
Yeah.
Well, let's wrap, I reckon.
Yeah.
Done.
Thanks so much for that, Aaron.
No worries. My
really
pleasure.
good example.
I'll just call out Tony saying looking forward to AWS recommending patterns for MFE composition. So that would be the second pattern. So yes, that will, it's coming. I just haven't had enough time to start documenting everything that I've been writing in code. So you know us developers, documentation is the last thing that we do.
That's it.
Excellent. Well, next week we're going to do same time, and it's going to be most likely on serverless with a guest star. So we're just roughing that in right now. But next week will be a nice serverless Lambda session, I believe. Paul, is that right?
Yeah, hopefully, if we get the guests we're getting, like it is planned, it'll happen at some point. If it's not next week or later, using like it's around testability of serverless applications. So should be a real good one, because that's the developers are, you know, there's writing code, writing documentation, and tests.
I thought you were originally going to write a book on tests one day, Paul.
Yeah, maybe that's a story for another day.
Done. Excellent. Well, thanks everyone for watching, and we'll catch you same time next week. See you all later.
Take care. Bye.
Thanks.
Bye.
Bye.